attempt to project the graphing calculator. And then I'm going to move this. Alright, so my goal here, hopefully, let's go back to this real quick. Actually, I'm going to stop screen sharing for just a minute, because I want to take a screenshot of who's here and who's not here. Okay, so I got a screenshot. Alright, I'm going to go back to sharing my screen. So if you're at home, what you're going to be seeing is you're going to be seeing the graphing calculator. I'm going to minimize this. Now, let's do this. Alright, this way maybe you're going to see me in the window. That's the whole point of that. And then when I write something in the board, hopefully you're going to be able to see it right up here. Alright, so somebody at home, tell me, are you seeing the graphing calculator being projected? So somebody at home has got to tell me yes or no. So undo your mic and say yes. Somebody? Pretty please? Emma, turn your mic on and then tell me, can you see the graphing calculator?
Yeah.
Okay. Yeah, don't be shy, guys. Don't be shy. Yeah, all right? Don't be shy. You got to talk to me. Okay. All right. Now, what I want to do is let that person in. Okay. This is going to be a learning experience for all of us. Let's pull this over here. Okay, first thing I want you to do, we're going to take a look at linear equations first, all right? You all know what a linear equation is, right? Okay, so, such as y equals 2x minus 5. All right, we know that is a linear equation in slope-intercept form. All right, we know that's a slope-intercept form, right? What's the slope of it? Connor, what's the slope of that? Ooh, guess again. Yep, 2. 2 is the slope, okay? And then the negative 5 is the, what's the negative 5? Grace, do you remember what the negative 5 is? Yeah, the Y-intercept? Yep, Y-intercept. It's going to be really hard for me to hear you guys. Just forewarning here. Okay, so this is a linear equation. We know that's the slope. Okay, we know that is the Y-intercept. Okay. I'm going to try to fix this video just a little bit better. Okay. All right, now I want to put this in the graphing calculator. Okay, so if you set this up on your laptop over the weekend like you were supposed to on Friday, all right, you should have watched the tutorials and you should be familiar with this. So what I'm doing in class now should be a review because you should have already practiced this because of what Friday's assignment was. All right, so what button do I need to hit on the graphing calculator to put an equation in? Yep, the y equals button. Okay, so we're going to hit that y equals. All right, now I already had one in there because I've done this example earlier today. If there's some other equation in there, which there's a really good possibility for the people that's sitting in the room that it's already there. All right, some other one is already there. Okay, if you hit the clear button right there, that would clear out any equation in there that you don't want. Okay, but I'm going to go ahead and put mine back in. I'm going to hit 2, and then I'm going to use the X, which is right next to the alpha key. All right, and then minus 5. Okay, so I'm putting that in there. Now, under most circumstances, all right, you can just hit the graph button. Okay, but later, when we start doing more complicated equations, you're going to necessarily, you're maybe going to want a standard window, or you're going to want to zoom fit. So we're going to play with all of that. On this one, let's just go ahead and hit graph. It should come up in a standard viewing window. All right, and we all know that line has got a positive slope. You can see it has a positive slope. You can see that it has a y-intercept of -5. Okay, so it's probably, it is accurate. Okay, but you can do a rough estimate and know it is. Okay. All right. Now, from here, all right, we should know, hopefully, what an X-intercept and a Y-intercept is at this point. Okay. So, I already know the Y-intercept because the equation is really easy. All right, we will get harder equations where we're not going to know what the Y-intercept is, so we're going to have to find both of them. Okay, but this X-intercept right here, X-intercepts and Y-intercepts are the points at which they cross the X and Y axis, right? So, technically, you could guess, and this one, like I said, it's an easy equation, so it kind of looks like 2.5. All right, but we don't want to do any guessing because when the equations get more complicated, it's not going to be 2.5. It might end up being 2.87 or 2.743. Okay, so we have to be extremely precise. Okay, so what I'm going to do is I'm going to have the calculator calculate that X-intercept. Okay, so I'm going to hit the second button. I'm going to go second, and then calc. Calc is above the word trace because the second button on my calculator is blue. So second, calc. All right, and then you get this menu right here. Okay, now I'm going to go back. Don't hit anything else. I'm going to go back to my graph for a minute. All right, this we know is the X-intercept. Okay, the X-intercept is also going to be called the zeros of the equation. All right, so it's also going to be called the zeros. It's also going to be called the solutions. All right, we're going to say real solutions. So the X-intercepts are the zeros and the solutions, real solutions of the equation. So those are the same words. They all mean the same thing. I'm going to take that set of parentheses out of there because we don't need that. So X-intercepts are the same thing as the zeros. They're the same things as the solutions. Now, let's do this. If it's a solution, I should be able to solve the equation and come up with the answer, right? Okay, so right now I can't solve that equation because I got an X and a Y in there. But if I replace Y with 0, okay, now stop and think about that. If I replace that Y with a 0, if I stop and think about ordered pairs, what did I just do? I have an X coordinate here for an ordered pair, and then this is the Y coordinate. Well, I just put 0 in there, right? So this ordered point pair, if I graph it, if this was like 6, 0, what would I do? I'd go over 6, and then I wouldn't move up or down. So it would end up on the x-axis. So it would end up as an x-intercept, right? Okay, so by putting 0 in here, I can solve that equation. Can I add 5 from both sides? I can add 5 to both sides. And then I can get 2x is equal to 5. At that point, you do what? You divide both sides by 2. Okay, so I can divide by 2 and divide by 2. So x equals 5 halves rather. All right, which is 2.5 if it's a mixed number. How far down can I go in the video? 2.5. Okay, and we guessed it does look like it. It's 2.5, right? Now, let's go back and do the second calc and have the calculator come up with that. All right, so you're ahead of me. Second calc. Now, in this list, I don't have x-intercept, do I? But we just said the x-intercept is the same as the zeros, and I do have a choice for 0. So I can either arrow down or I can hit 2. All right, hit the 2 and then just stop, because what it's going to do, if you look down here in the bottom left-hand corner, it's going to say left bound. All right, which means left side. Okay. All right, I'm going to go second quit and get out of this and do it again. Okay, so here's my graph, right? Then I went second calc to get that menu. And then I press 0, number 2, to get the x-intercept. Is everybody with me that's in the room? Okay. All right, now it says left bound All right, now stop and think about this. Right here, all right, is my x-intercept. You got to think of the graph going left to right, okay? So this down here is the left side of that x-intercept. Does that make sense? And then if this is the x-intercept, then up here would be the right side or right bound. Okay, so that blinking cursor right there is on the left side. All right, I could move it anywhere on the left side. It really doesn't matter where I put it, just so it's on the left side. All right, once I get it there, I'm going to hit enter. And what the calculator is going to do is it's going to put a line right there. And then it switches down and it says, okay, what's the right bound? So you're going to use the cursor, you're going to move the arrow to the right side, anywhere over there on the right side. All right, and you're going to hit enter. All right, now it put another line over there where that cursor was. Now down in the left-hand corner, it's asking for the word guess. So it wants you to guess at where it's at. So you're going to take that cursor and you're going to move it back close. Technically, you don't have to be exactly on it, and it may not fall on it easily, but you can try. And then you hit enter. And what it does down here is it finds the x-intercept as the ordered pair 2.5 and 0, or it also just finds the solution to the equation of 2.5. All right, so right here, if it's 2.50 and it's written like this, that's a y-intercept. Okay, if I write it like this, x equals 2.5, then there I'm writing it as a 0 or a solution to the equation. Okay, let's go down a little bit so maybe they can see that at home. All right, so when I write it as an ordered pair, it's a y-intercept. I just said y-intercept, that's my x-intercept. Let's fix that. X-intercept. All right, when I write it and when I put it in the equation, set equal to 0 and solve it, I get the 2.5. I still get this number. I still get 2.5. But because this is a solution, I'm going to write it different. It's going to look differently. Okay? All right, now, obviously on this one, we know what the y-intercept is. Y-intercept, we said we already know it's -5. But let's suppose you didn't know it. All right? Now, if I didn't know, I'm going to go up a little bit here. We know this is the y-intercept, but if we didn't, that's okay. What's the ordered pair look like for a y-intercept? What's the first number? If I plot a point and it lands on the y-axis, the first ordered pair, the first number has to be 0, and then I'm going to have a second number. And like I said, on this one we know it's -5. But if we don't know what it is, all right, the calculator will do it for you. So I'm still on my graph here. If I do second calc, there is tons of stuff in that second calc. All right, now nowhere on that list does it say y-intercept. So you just have to know that if you're trying to find a y value, you're going to hit number 1. Because if I hit number 1, then down here in the bottom left-hand corner, it says x equals. And it's going to let me put in any value I want for x, and it will tell me what the y is. And in this case, I want the x to be 0, right? If I'm trying to find the y-intercept, so I'm going to punch in a 0, and then I'm going to go ahead and hit enter, and it spits out the -5, which we knew it was going to be because we knew what it was. Okay, so I just want to double check here. Emma, turn your microphone on for a minute because I want to ask you a question. Okay, so can you see the graphing calculator and the line and everything that I am pointing to?
Yeah.
Okay, I just wanted to make sure I'm projecting it because like I got about a zillion things open on my laptop and I just want to make sure it's working. Okay. All right. Okay, so just double checking there. All right, now let's do a little bit more with this. Let's go to the y equals. Okay. And let's do another shape that at this point you should know. Okay. If I did something like I did something like y equals parentheses x minus 4 squared plus, let's do plus 5. All right, now you probably have not done anything like that, like when you were in 8th grade or when you was in the 8th grade algebra class or anything. Okay, but with what you know, it's got an x squared in there. It's got a squared. All right, anything that's an x squared is what shape? You did x squared, a parabola. Okay, it's going to be a U shape. It's going to be a parabola. Okay, so even though this is like really complicated, you did easy ones like x squared, or maybe 2x squared or something like that. You did easy ones. All right, this just is in a different form. Okay, this is actually called vertex form. Okay, that's actually called vertex form. All right, and what we're going to do is we're going to graph it and look at it. So that's why I went ahead and hit the y equals button. All right, I don't want this linear equation in here anymore, so I'm going to clear it out. And I'm going to put in the new equation. So, left parentheses, x minus 4. Make sure you use the minus button right there. Close the parentheses. All right, and then you got a couple different ways to do it. There is an x squared sitting over here on the left-hand side. You could also do the caret and then a 2. Either one, doesn't make any difference. I usually, on an x squared, I usually just do x squared because then it pulls the cursor back down here where I need to be. And then I can go ahead and finish entering the equation of plus 5. Okay, now, on this one, all right, we're going to just zoom on a standard window. Okay, so technically, yes, could I just hit graph? I could. All right, but I want to see what this looks like on a standard window. So this time, instead of hitting graph, I'm going to hit zoom. And then I get this window, and I've got lots of choices in there. And actually, if I use the arrow and I scroll up and down, I've got even more choices. Okay, but 6 right there is that Z stands for zoom. So zoom standard, which means it's going to put the calculator in a standard window. So negative 10 to 10 on the x-axis left to right. All right, and then negative 10 to 10 on the y-axis. All right, so I'm going to zoom 6. It put me in a standard window, okay? And from that, can we tell it's a U shape? It's a parabola. It's a quadratic, okay? Now, are there any x-intercepts? Does it cross the x-axis? Nope, because the x-axis is all the way down here. So clearly it's an upright. It's going to keep going up and up and up. It's not ever going to cross that. So there are no x-intercepts, and that's okay. All right, which also means there are no real solutions. All right, later chapter will address that, okay? But there's no real solutions. Okay, now, does it have a y-intercept? It does, right? It has one. Can we see it? You can't see it, okay? So you've got to learn how to adjust your window. There's lots of ways to adjust the window, okay? But down here, I don't need any of this stuff because the graph's not down here, okay? Ooh, that's not a good sign. I lost internet. Hope they all just stay put, people. Mid-lesson in case I didn't record the first half of this. All right, so we were talking about finding that y-intercept, and I've got to adjust the screen. Lots of different ways to adjust the screen, okay, but I think the easiest way is to just manipulate the axis. All right, now, down here, this would be negative numbers, right, on your coordinate plane. So this down here is considered a y minimum. All right, these up here would be really big numbers, positive numbers, so y max. Okay, same thing on your x-axis. This over here would be x min, and this over here is going to be x max. Okay, so if I go in and I hit the window button, okay, what comes up is that standard window. We knew it went from negative 10 to 10, all right? So there's your x min, your x max, your x scale, because you can change the scale. It doesn't have to count by ones. All right, if I wanted the maximum of part of this, the y-axis to go all the way up to, say, 1,000, I don't want to count by ones. I might count by 500s or 1,000, okay, so I can change the scale. All right, now, left to right on that graph, it was fine. I didn't need to move left to right, so I don't need to move anything on the x-axis. But I do need to maybe move, okay, my y max. That I need to see more at the top of the graph to be able to see that y-intercept. So I don't know, to be safe, let's put 50 in there. Okay, and 50 is not bad. I could count by 50s there. Okay, now the other thing, let's go back up a little bit. And this is all subjective. You just have to put numbers in that you think are going to work for your graph. I didn't need anything below the x-axis, right? Because there was nothing down there. So I don't need something as big as -10. I could probably do -5. It'll shorten it up just a little bit. Okay, and then I'm just going to automatically hit the graph button. It's going to adjust that window. Okay, so now can I see the y-intercept? I can see the y-intercept, but do I know what it is? No. And back here to this equation, looking at this, you can't find the y-intercept. Not yet, anyway. You will be able to later. Okay, you just can't do that right now. So we're going to let the calculator do it. When we wanted the y-intercept, we did what? We did second calc. And then which one did we use? We want the y-intercept, because we just did it a minute ago, but you have to remember. Anybody at home remember what we used to find the y-intercept? And they're all like, no, not a clue. Are you paying attention out there? Are you guys all asleep? They all have their video turned off. I can't tell if they're really there or not. Okay, all right, so it's the 0. Okay, or not 0, sorry, just said that wrong. It's the value. All right, so I'm going to hit 1, because what's it going to do? It's going to come up here and it's going to ask me for my x. If I'm trying to find that y-intercept, it's going to be 0 something. Okay, it's going to be 0 something, so I'm going to punch in 0. I'm going to hit enter, and it's going to spit out 21. Okay, so my y-intercept is 0, 21 for this graph. It has no x-intercepts. The y-intercept's 0, 21. Okay, but we couldn't really tell, and you don't want to try to graph. You want to know precisely what it is. Okay, now, something just getting ahead of ourselves just a little bit. I was wanting a blue pen, but maybe not. Okay, all right, I said this was vertex form, right? We all know what a vertex of a parabola is, right? So if I have a picture of a parabola, then this right here is the vertex, right? The point at the bottom or the top, depending on how your parabola looks like. All right, now, it's in vertex form because the vertex is hidden inside there, okay? Now, we're going to talk more about this later, all right? But this number is considered to be on the inside of the function, all right? It's considered to be on the inside of the function. This one is considered to be on the outside of the function, okay? Because my main function here is something being squared, okay? If it's on the inside, we go opposite left or right when we graph, okay? If it's on the outside, we do same up or down is how we move, okay? Now, watch my cursor because I'm going to do it on the screen here. If I start at the origin and I do the opposite right here, I see -4, which would be left, right? But what's the opposite of that? Going to the right 4. So if I start at the origin and I go to the right 4, 1, 2, 3, 4, and then this is whatever number I see the same. I see a +5, so I do the same thing, and I go up 5 because 5 is positive. Then I go up 5. Right there, that puts me at the vertex. The vertex of this parabola is 4, 5. Okay? So where can I write that they're going to be able to see that? All right, let's try it right here. Vertex 4, 5. And it's in the equation because it's in vertex form. Okay? It's in vertex form. So more information of things that you have now, hopefully you've learned some of this, like I've not totally mentioned things that you haven't ever heard of, okay? We know parabolas, we've got some vertexes, and we're trying now to take some of those basic skills that you learned last year and then apply them to the graphing calculator to have us help, okay? So I'm going to go see what that noise was. Maybe I'm going to go see what that noise was. Nope. I thought maybe somebody was trying to get in. Maybe not. Okay. All right. Now let's do another type of equation. Okay, and we definitely don't want to use that blue pen because that blue pen marks up my board. Okay, so no more blue pen. Blue pen goner. Throw it away. Okay. All right. Let's do an equation that looks like y equals x to the third. Okay, y equals x to the third. Okay, now you probably didn't do that last year, would be my guess. Probably not. Okay, this is called a cubic equation. All right, and it is a base cubic equation. Okay, so you guys don't know what it looks like. So let's go into y equals. All right, clear out that equation and put in an x to the third. Now, an x to the third, you're going to hit the x button, okay? But then you're going to have to use the caret this time. The caret's right above the divide by sign. So it raises it up. It puts it in the little exponent spot right there. So now you can type a 3. All right, now, if there were more parts to the equation, I would need to arrow to the right to get that cursor back down to where the x is, okay? But x to the third is the only thing there. All right, now, the last window we used had weird window settings, right? We don't want weird window settings. We want just a standard window. Somebody's trying to get in. I'm going to try to fix that here. So we're going to zoom standard, all right? And it's going to attempt to go in. Let's go in here. Yeah, let's admit. Yeah, I was trying to let that person in. Okay, I'll move this out of the way so we can now see our graph. Okay, so we've got an x to the third there now. So I call that a squiggly S-y thing. Okay, it's really in a cubic equation, but right now it's our squiggly S-y thing. All right, now, cubic equations do not have vertexes. Okay, like a parabola has a vertex. But a cubic equation has what I like to call of a turning point, okay, because your basic x to the third looks like this, okay? And right about in here, it shifts, right? It turns and goes the other direction. So I call that a turning point. Okay, I call that a turning point. Okay, because, and on this one, where is it? It's right there at 0, 0. All right, so we're coming up here, and then it kind of shifts and turns and goes the other way. That's why I call it a turning point. Okay, now, if I take this basic equation, and I kind of write it like I did with that x squared just a little bit ago, all right, I did what? How about like a y equals parentheses, and then let's do x. This time, I don't know, let's do plus, say, 3 to the third power, and then let's do minus 5. Okay? So, does that look like vertex form? All right, the only difference from this and what we did just a minute ago, I had a 2 right there, so it was a parabola, but I called it vertex form for the parabola. Okay, now I've changed that to a 3, so I know it's a cubic equation, but I still have an inside, I still have an outside. So I have vertex form, so that's vertex form right there, okay? Or at least I call it vertex form. I don't really know what math books call it, but because it makes sense. It's not going to give me the vertex, but it's going to give me the turning point, okay? And the rule remains the same no matter what equation I'm looking at, okay? So this right here, is that on the inside or the outside of the function? It's on the inside, right? So opposite left or right, is how I'm going to move. All right, and then this is clearly outside the equation. So this is going to tell me how I move up or down, same. So same, up or down. Okay, so we'll graph it here in a minute, but let's just stop and think about this. Okay, so here's the origin. All right, I just said that I'm going to go opposite of that plus 3, so minus 3, so to the left 3. So if I went to the left 3, and then I went down 5, so 1, 2, 3, 4, 5, right about here is going to be where the turning point is. Okay, right about here, to the left 3 and down 5 is going to be where that turning point is. Okay, so let's go in and see. All right, let's go into y equals. Now, I want to leave x to the third there, because in the graphing calculators that show color, okay, the x to the third is going to be blue. If I arrow down, whatever I put in y2 is going to be red. Okay, so let's put that equation in. So we'll go parentheses, and then we're going to go x plus 3 parentheses raised to the third power. So do the caret to get it to go up. That's where your exponent goes. I can put a 3 in there. Now, you got to remember to arrow to the right, because if you don't, when you put the minus 5 in there, you're going to be in the exponent. You don't want to be in the exponent part, okay? So, minus 5. So, make sure that when you put your equation in y2, it looks like that. Okay, are we all good here in the room? Okay. All right, now, this time I've got an equation in y1 that's going to be blue. I have the shifted equation in y2, which is going to be red. So if I just hit graph, because I was already on a standard window, it keeps the blue line there, and then it adds the red one. Okay, and I had said, what, if we start at the origin and we go to the left 3 and down 5, it's going to put that turning point right about there, and it did. So it kind of shifts it around the thing. So I'm trying to cover, like, you hadn't seen the cubic equations before, so this is a nice little introduction to it. This idea of when it's on the inside, we shift opposite left or right. When it's on the outside, we shift same up or down. We will go into more detail about why that is, okay, because right now I'm just telling you that's something you can memorize. It's going to work. All right, but there is a reason for it, okay? There is a reason, and we will touch on that. I just want to kind of touch on x and y intercepts. I wanted you to see a basic x to the third and how it shifts. I wanted you to see the basic parabola, okay? And then I wanted you to be able to change that window. All right, now I do want to do one more thing that wasn't on the list, but I want to do it, okay? Let's go back in there to the y equals, and then let's just clear out both those equations. So let's clear out the x to the third. Let's clear out that one right there. I'm going to arrow back up. Okay. What I'm about to show you was not in the videos. If you watch the tutorial videos like you were supposed to, this was not in there. So this is an extra thing, or at least I don't think it was. All right, so on this first one, I don't know, let's put in, I don't know, let's go, what's that going to do? Let's do a 2x, and then let's do minus, no, let's not, yeah, I don't know. No, let's not do minus. So let's back up and do, let's delete that and then put a plus sign there. Let's go 2x plus 5. And then let's arrow down. Now let's put us a parabola in there. Now I'm going to show you two little things. We're going to put an equation in. It's going to be wrong. I'm going to show you how to add something. Let's do an x squared. So let's do x and then x squared. And then let's go plus, I don't know, 8. All right, so I'm just randomly making up those two equations at this point. Okay, now let's go ahead and zoom standard. I mean, we should be on a standard window, but if not, let's go zoom standard, which is zoom 6. All right, so I got a straight line, and then I've got a parabola. You can barely see the parabola, but it's an upright parabola, right? And I've got a line. Okay, do they intersect each other at all? No. If I wanted those two to intersect, what would I have to do to one of them? How could I change one of the two graphs if I wanted them to intersect? Does the parabola always have to go upright? Can the parabola go upside down? Anybody remember how it goes upside down? Aha! Does anybody remember how to make the parabola go upside down? Okay, so if I had y equals, say, 3x squared, is that going to be upright or upside down? That one's going to be upright because this is positive. All right, so I know that is upright because it's positive. But if I went y equals negative 3x squared, this one's going to be upside down because that leading coefficient is negative. All right, so again, I'm hoping that you remember that from last year, okay? But again, if not, we're going to go over it multiple times, so you don't have to. So let's go back into y equals real quick. All right, so let's say on the parabola here, I want it to go upside down. But I don't want to have to clear that out and type that all over again, okay? That's too much work. I just want to insert a negative, okay? So right above the delete key is an INS, which stands for insert, and it's in blue on my calculator. So if my cursor is blinking right there on top of the X. If I do second insert, okay, it kind of changed there, and now I can put, now don't hit the minus button. I want a negative, and the negative is down here in the bottom right-hand corner. So you hit that negative, and it just scooted the equation over. It inserted it in the equation where I want it. Okay, so now I've got negative x squared plus 8. Now let's go look at our graph. Is everybody in the room with me so far? We got our negative in there. Are you good? Okay, because I can do it again if we're not. Okay. All right, so I'm going to zoom standard just to be on the safe side. So I'm going to zoom standard just to be on the safe side. There's my straight line. And then I've got my upside down parabola now. Okay, now, do those two graphs cross each other anywhere? Yeah. How many places do they cross? In two locations. Okay? So when something crosses, I don't have to say the two graphs cross. I could say the two graphs intersect. Okay? They intersect. I could find those exact values at where they intersect. Because it should be an ordered pair, right? Because I'm going to go over to the right and I'm going to go up, and then that's going to create an ordered pair right there. I could go over to the left and then down, and it's going to give me another ordered pair. The calculator will find those for us. Okay? So we're going to do second calc. All right, and then that menu comes up again. Okay, now this time what are we doing? We're looking for the intersection points, so we probably ought to pick 5 for intersect. Okay, now after you do that, just wait for a minute. Okay, now the calculator is really, really smart. It says first curve. The cursor is blinking on that blue line. And in Y1 we had 2x plus 5. Everything's in blue. It knows that's the first curve. All right, it's going to automatically come up with the first curve every time. Okay, then I'm going to hit enter. All right, and again, calculator is really smart. So the cursor jumped over to the second equation, which was the upside down parabola. It's now in red up here at the top. It's in red down here at the bottom, and it's asking you, is this the second curve? Even though it already knows it is, it's still asking you. All right, so then I'm going to hit enter. All right, now it says guess. It wants you to guess where that is. So the blinking cursor is right there at the top of that parabola. So I'm just going to start scrolling to the left. And I want to find that intersection point right there. Now I'm not going to be able to get exactly on it, but I'm going to get close. Okay, and then I'm going to hit enter. And that intersection point is at -3, -1. Okay, so my intersection points for what we just did is -3, -1. So I'm going to write intersection points. All right, above this, I'm going to go back and write what the two equations are, okay? So I'm going to go back and look at y equals. All right, so I've got a straight line, y equals 2x plus 5, and then I've got a y equals negative x squared plus 8. All right, so for these two, I've got one intersection point at negative 3, 0. Now, if you want to find the other intersection point, you got to do it a second time. However many times they intersect, that's how many times you have to do it. Okay, so second calc got us the menu. Second calc got us that menu. All right, and then we're trying to do what? We're trying to find another intersection point. So we're going to pick 5. Okay, and then again, it comes up and it knows the first curve. Now, it is blinking right there at that intersection point because that's where I left the cursor. All right, if I move the cursor to the right or left, I can clearly see it is on that line. It's on the first curve. Okay, so I'm going to hit enter. It automatically jumped to the second curve, which is the parabola. Okay, and so it's in where it's supposed to be, so I'm going to go ahead and press enter. And then it wants me to guess. Well, this time I want to guess this intersection point over here, so I'm going to arrow to the right and get it as close as I can. Doesn't have to be perfect. I'm going to hit enter, and it's going to spit out 1, 7. It gives me the x value down here. It gives me the y value. So my other intersection point is 1, 7. So I can find the intersection points of where those two graphs cross. Okay. Okay, so we've actually done quite a bit. All right, we have done a lot. We found x-intercepts, we found y-intercepts. We've talked a little bit about straight lines, parabolas, and cubic equations. We've introduced vertex form and how to shift to find the vertex, how to shift to find the turning point. We've talked about intersection points if I had two different types of graphs in there. Okay, now your job is to practice with this on your graphing calculator so that you're really good at it. Okay, we will take quizzes where I will give you problems, all right, and then you've got to use your graphing calculator and get the answers, all right, because I wanted to train you or teach you how to use it. Okay, so we'll take baby steps to begin with. Initially, I think one of the videos you had to watch was the fraction button. Okay, I'm not going to demonstrate the fraction button in class because that one was kind of straightforward. All right, but if you did not watch those videos, you need to watch those 5 videos, okay, and just go through the tutorials and go through them until you have it memorized and you just know what to press. Okay, it's almost like learning a video game or whatever. You just got to know what to do, where to go, what to press. Okay, all right. So are we pretty good? For a first nice little introduction, okay, we will go over this stuff more than once, okay, but you got to practice on your own this week. All right, everybody that's at home on the Zoom, does anybody have any questions? If you do, open your mic up and ask if you've got any questions. Because I can see your little microphones over here, so I can see if they're turned on. Okay, it kind of looks like nobody's turned their microphone on, so they're either shy, they've walked away from the computer, and I don't really know it, or they don't have any questions. All right, and so then tomorrow we're going to do this exact same thing, except it's going to be switched. I'm going to have everybody else in the room, and then you guys are going to be in your little Zoom meeting. Okay, we're going to try to do that. Except I probably won't be projecting from my computer. I'm going to try to make it work so that I'm projecting from what I write. Because like me, notice how I've got the laptop turned up there. It's real tiny. It's not very good. So. Okay, all right, so I'm going to end the Zoom meeting. Well, first of all, I'm not going to do that first. I'm going to stop sharing. Okay, so I'm going to stop sharing. Okay, so bye. Thank you for joining me today. Let's hope this all worked really, really well. And if not, we'll perfect it later. Okay, we'll perfect it. All right, so I'm going to go ahead and end the meeting. It's going to cut you guys out. I am going to try to get this video loaded later on the website. Okay, so, all right, so I'm ending it. So, there you go. Okay. I feel like a